Everyone, welcome to my channel. So in this video I'm going to introduce how we are going to solve this problem called Pacific Atlantic water flow, and at the same time I'm going to introduce the general steps we should follow in the real coding interview. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel because it can really help me to grow. So thanks a lot. Then let's get started. First, let's read through this problem. So given an n by n matrix of non-negative integers representing the height of each unit cell in a continent, so the Pacific Ocean touches the left and top edges of the matrix, and the Atlantic touches the right and bottom edges. So water can only flow in 4 directions from the cell to another one with height equal or lower. So find the list of the grid coordinates where water can flow to both Atlantic and Pacific Ocean. So the order of the returned grid coordinates doesn't matter. Both m and n are less than 150. So there's no constraints here, which means potentially the matrix could be a empty one. So that could be a edge case we definitely need to consider. But let's read through this problem. So for this one, this cell is reachable for both sides because there is a path to the Pacific, there is a path to Atlantic as well. So similarly for all of the numbers in the parentheses, because there is a path to both the Pacific and Atlantic, so we are going to show them in the result. So the solution generates like a BFS solution. So let's go through this piece of code, and I'll introduce how we read this. So this is a major function we implemented. Essentially, we have a reachable by both. This is a linked list. So we have first we check if the number of the row is 0. If yes, then we just return it. We return a empty list without doing anything. And the second one, we check if the column number is 0. If yes, we just return empty thing. So essentially those are edge cases to make sure that the matrix is not empty. Otherwise, we will call BFS to compute. This is a helper function to compute all the reachable cells by Pacific, and call BFS to calculate all the reachable cell by Atlantic. And then finally we do a merge about all the cells reachable by both of the ocean. So let's go through this helper function, which is a BFS function. And also so here we define a helper function, which is super easy. So this one is to turn a pair into a list. So you can see that and then initiate a linked list and put the position key and position value into the list. So the position key is the row number of the position of the cell, and the position value is the column number of the cell. So let's go through this BFS helper function here. So for BFS we have we have 3 things: the matrix and the start row and the start column. So the start row is which row is touching the ocean, this corresponding ocean, and the start column is which column is touching the corresponding ocean. So remember, in BFS we have essentially the visited and the queue, and here we also have the positions to record down the reachable cells by the corresponding ocean. So first of all, we added all the positions that is touched by the starting column. So we are going to have everything added into the queue, and then everything touched by the starting row. So in the BFS, first of all, we get the size of the queue, and we pull every of the position from the queue and add it into the final positions, and try to extend from the current position to the rest in 4 directions. So I define a helper function which is called extend. Let's read through this. So we have the position of the current position, and we have the queue, we have the matrix, and we have the visited set. So first of all, we define local variable, which is a column and the row number of the matrix, and then for directions, we are going to reach from the position. So we compute the new position based on the direction. So if it is already visited, we continue. If it is out of range, then we continue. If the new position has a lower height than the original position, then we continue as well. And finally, we will have we will add the corresponding new position you visited and into the queue. So that's pretty much about this extend. So the extend helper function is to extend in 4 directions. And finally, we are going to return all the positions that is reachable in this BFS helper function. So that's pretty much it. Like we call the BFS to compute all the reachable cells by the Pacific Ocean and Atlantic Ocean. Then we do a final merge. So the runtime is going to be O m by n, and space-wise it's also going to be O m by n. So that's pretty much it about the solution. And regarding the procedure to follow in the coding interview, so remember, don't jump into the coding part too quickly. Try to understand the problem, ask some questions to clarify, and think about some edge cases. And then you will need to talk about the idea how you're going to solve this problem with the interviewer, do some runtime space analysis to justify the efficiency of the approach. And if you get an agreement, please get started and do some coding work. So for coding, take care about the maintainable readability, and also correctness, and also don't be too slow. And at the end, you need to really test this piece of code by setting up some test cases. So that's it for this coding question. So if you have any question about this specific problem or anything, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.